All right, this lesson is going to focus only on balancing chemical equations. To learn about the chemical equations and the vocabulary we use, you should be watching the chemical reactions video. All right, I'm going to start by just noting that we are, let me make sure I'm getting my inking here. We are on Unit 5. So balancing equations and types of reactions is the unit. Our focus today is on balancing. And then balancing chemical equations properly. All right, so from the first example in the balancing chemical equation worksheet that you were to do, I'm going to write out the problem and we're going to go over the information. From the video going through the details, we know that the arrow represents to produce. We know that the left side of the equation are the reactants. I'm going to denote that as a capital R. We know that the right side are the products, and I'm going to denote that with a P. In this case, we have a product. I also want to point out N2 and H2. So we have a nitrogen atom and we have a hydrogen atom. However, there's two of them. There's something that we need to make note, and I'm going to write down the word here. It's called a diatomic element or atom. Or atoms. What that means is that we have two atoms put together. So there are 7 nonmetals that found in nature, so in the atmosphere. They are never by themselves. So they can be connected to another atom in a molecule, such as the product here. We have nitrogen and hydrogen connected to make ammonia, NH3. However, when they're written by themselves, they're never written by themselves. They're actually written diatomically by 2. So 2 atoms. Remember the prefix di means 2. So in this case, I'm going to write down the diatomic elements so we can make note and know them. And there is a way, I just made a word out of this. It's not a word at all, Honkelbrief. It's just a funny kind of Dr. Seuss type of word, which means that the Honkelbriefs are diatomic. So all of them are found in nature with a 2 of them. So this is the first thing we need to make note of. Again, the balancing chemical equations, when I give you the actual formulas, you're not worried about that because I wrote them properly. However, if I were to write nitrogen gas or hydrogen gas or oxygen gas or chlorine or bromine or iodine or fluorine, you need to know that the formula would be diatomic, so we would in fact have to write the number 2. All right, I'm going to scroll down now a little bit further, and I'm going to show you the work behind how to balance it. All right, so the reasoning why we balance, and we learned from the previous video on the details of the vocabulary, is because of the law of conservation of mass. It says no atoms can be created or destroyed. In fact, if we have, in this case, 2 nitrogen atoms on the reactant side, we must have 2 nitrogen atoms in the product side. Of course, in a different form, because this is a chemical reaction producing different elements or different compounds or different molecules, but we still have to have the same value. Nowhere are we allowed to change the subscripts. The subscripts, if they're changed, are no longer that atom or that molecule or that ionic compound. So what we do then instead is we add a coefficient in front of any or all of the elements, compounds, or atoms. In this case, these are atoms and molecules. So I'm going to show you the work on how to balance the equation. I'm going to start with a T-chart. I'm going to put R for reactants, P for products, and I'm going to make note of all the atoms that I have present. I have 2 nitrogen atoms on the reactant side. I have 2 hydrogen atoms on the reactant side. On the product side, I have 1 nitrogen atom. I don't have a value there, so that's denoting a 1. And I have 3 hydrogen atoms. Okay, I've separated them out so I can clearly see that I am not balanced in nitrogen and I'm not balanced in hydrogen. The rules of balancing I had you note from the previous video. It says to start with the more complex molecule. And here we really don't have a complex. I guess NH3 would be the more complex because they're together. So we will start balancing from the right side, the product side. If I put the number 2 in front, it is distributed to both of the atoms, which means then I have 2 atoms now of nitrogen on the product side, and I have 2 times 3, I have 6 atoms of hydrogen. So yes, I'm now balanced for nitrogen, however my hydrogen atoms are still not balanced. If I look at the reactant side and added a 3 coefficient in front, I would then be changing to 6 total atoms of hydrogen. So you can always double check your work instead of just looking at the answer key. You can also just double check to see if you have the same amount. So I'm going to highlight how many I have here. I have 2 nitrogen atoms on the reactant side. I have 2 atoms of nitrogen on the product side. Here I have 6 atoms of hydrogen on the reactant side, and because of this, 2 times 3, I have 6 on the product side. So because I am even, I have 2 and 2 and 6 and 6, we are considered a balanced equation. All right, let's go forward and do another example. I'm going to focus my example on number 6. I have a little bit longer of a problem here, so I have aluminum bromide plus, get a lot of eraser marks here, sorry about that. We've got potassium sulfate, K2SO4. It yields, I'll write out the equation for number 6. Oops, that's a 3 right there. All right, first and foremost, I want to make note that I have written out all of the formulas here. And what you need to remember is Unit 4 is critical to review, review, review. If you do not write your formula correctly from, let's say if I gave this all in Word form and I asked you to write the formula, if you don't write the formula correctly, you won't be able to balance correctly. Okay? This is something that we need to continue to go back to Unit 4 and keep practicing. All right, so let's get into balancing. Now, we don't actually have lines that go underneath that we need to write in front of each of the elements, or I'm sorry, the ionic compounds here. However, for teaching purposes, I'm going to write them just so we're focusing on what we can change, which is the coefficient, the number in front. Note again, I am not allowed to change any of those subscripts. They are there for a reason. For example, aluminum sulfate here, sulfate had a -2 and crisscrossed the charges of aluminum with a +3, and you came out to be Al2 parentheses SO4 and a 3. All right, so let's make a T-chart. I have my reactants and my products. Again, until we're very comfortable with balancing equations, I want you to continue making a T-chart to confirm that you are correct. You will not be responsible for showing me the work of each problem and how you balanced it. You'll just be expected to be balancing from this day forward. All right, so let's take a look at the possible atoms. On the reactant side, I have aluminum, and I have 1. Bromine, I have 3. Potassium, I have 2. And then we have an SO4. So this is where I'm going to stop and explain that if we have an anion, that's I guess a cation, 2 for NH4, but an anion that are identical on both sides. So SO4 is the same SO4 on the right side as it is on the left. I can keep those together in as an anion form. So because of that, I'm going to keep it at SO4 instead of separating the S and separating the 4. It'll be a little bit easier to balance. So I only have 1 molecule of that on the left side, the reactant side. All right, let's take a look. Note that I'm going to put aluminum next to aluminum so I can compare easier. I have 2 atoms of aluminum. I have 1 atom of bromine. I have 1 atom of potassium. And my sulfate, if you note that I have 3 over here, so I have 3 molecules of sulfate, SO4. So nowhere am I balanced, and this is where I need to now figure out which one is the more complicated. Well, I'm going to stick to SO4. Seems a little bit more complicated. There's more in that, so I can start here. Again, you don't have to. I'm just showing you where I would start. So if I have 3 on the product side, I'm going to put a 3 coefficient and see if that's good enough for the sulfate. And in fact, it changes sulfate to 3, so now I'm balanced. However, remember that this gets distributed to both. So when I change SO4 to 3 on the reactant side, I also have to change potassium to 6. It's okay, I have one thing balanced. Let me go back and forth and figure out what else I can do. If I have 6 potassium on my reactant side, I can put a number 6 in front of, on the product side in front of potassium, and that would change this to 6. However, remember that it gets distributed to the entire ionic compound. So now I have 6 bromine. So I'm going to go back and forth again. And I'm going to go back to the reactant side and see what I can do. If I have a 3 as a subscript here, 3 times 2 would actually give me 6. So 3 times 2 would give me 6. But by doing that, it also changes my aluminum to 2. What's nice about what just happened is that now I naturally changed aluminum by putting the coefficient 2 in front for bromine. I've changed the aluminum to 2, so I am balanced on aluminum, balanced on bromine, balanced on potassium, balanced on SO4. This would be saying, if I left it blank, would be saying I have 1. It is not required to write the number 1, just like it's not required to write the subscript 1. So again, I'm going to check myself without even having to check the answer key. This is something that you can ask yourself at the end. Be like, am I right? Well, let's take a look. Let me make sure I'm highlighting here. I have 2 atoms of aluminum on my reactant side, and I have 2 on my product side. I have 3 times 2, which is 6 atoms of bromine on my reactant side, and I have 6 atoms of bromine on the product side. I have 6 atoms of potassium on my reactant side, and I have 6 atoms of potassium, I'll just cover it up like that, on my product side. This is going to be darker. I have 3 atoms of, it's really dark, so I'm going to leave it right there, 3 molecules of SO4, excuse me, on my reactant side, and here I have 3 as well outside the parentheses. So I've already triple checked everything to make sure everything is balanced, and we are correct. Alright, so now it's time for you guys to practice on your own.